Alright, today we look at one-to-one functions, part 2. And hopefully by the end of today we can prove functions or relations are inverses. And we'd like to be able to sketch the graph of an inverse. Let's take a look at this proving functions are inverses of each other. And there's a nice little theorem that goes along with that says if f of x is a function and f to the negative 1 of x is its inverse, then the composition of those functions, f of the inverse of f of x, yields just x. And it works the other way around. The inverse of f of x equals x. Alright, so let's take a look at a nice little example here. Are f of x and g of x inverses? Well, I don't know. Let's find out. If f of x equals negative 2x plus 3 and g of x equals negative 1/2 times x minus 3, well, let's look at f of g of x, where we'd have negative 2 times negative 1/2 times x minus 3 plus 3. Well, if we do all the algebra there, yes, we get x. Now, if we look at g of f of x, we get negative 1/2 times 2x plus 3 minus 3 okay, and when we do that, again, we get x. Therefore, they are inverses. Now, let's take a look at another one. Let's take a look at f of x equals x minus 5 over 2x minus 3, and g of x equals 3x plus 5 over 1 minus 2x. Well, let's take a look at f of g of x. So what I'm going to do is wherever I see an x in f, I'm going to put what g equals. So I'm going to have 3x plus 5 over 1 minus 2x minus 5 over 2 times 3x plus 5 over 1 minus 2x minus 3. And let's do some simplification here. Let's take a look. Let's get common denominators in numerator and denominator in our complex fraction. 3x plus 5 over 1 minus 2x minus, and this is going to give me 15x plus 25. Oh, no, it's not. This is going to give me minus 5 plus 10x over 1 minus 2x. And all of this is going to be over 6x plus 10 over 1 minus 2x minus 3 plus 6x all over 1 minus 2x. Well, let's take this on to the next page here, and we're going to have 3x plus 5 minus 5x minus 10x. And that's all going to be over 1 minus 2x. And all this stuff is over. And it's going to become 6x plus 10 minus 3 minus 6x. Six x plus 10 minus 3 minus 6x. And that's all over 1 minus 2x. Alright. Well, through some quick flashes and multiplication, those two things are going to cancel out. Now, if I can combine some like terms here, 5 and minus 5 cancel out. 3x minus 10x is minus 7x. And that's going to be over, let's see, 6x and minus 6x are 0, 10 minus 3 is 7, and that gives me negative x. Well, that's revolting. Let's see, did we make a mistake anyplace? Did I make a mistake anyplace? So I went 5. Oh, wait. Wrong way. This should be I think this needs to be a negative, that needs to be a plus, there's a plus. And there we go. Therefore, inverses. Okay? Alright, let's try one more example. Okay? Let's take a look at f of x equals x minus 2 squared, and g of x equals the square root of x plus 2. This time let's find g of f of x. So I'm going to have the square root of x minus 2 squared plus 2. That becomes x minus 2 plus 2, which is, lo and behold, x. Therefore, inverses. And all is right with the world. Let's take a look at graphs. Well, I'm running out of time here on this one. Look for part 3 on graphs. Thank you.